Today I'd like to talk about the Watson swine model, which is one of the digital tools from Trouw Nutrition. The Watson model has been in existence for quite some time with various different versions. The latest version now includes a sustainability module. The model uses information from the farm, such as the feed, the genetics, the housing and the management, and also some of the health factors. So these can be put into the model to simulate the performance on the farm, and then it can be used to make changes to see if we can improve the performance, such as changing the housing, changing the stocking density, or looking at improving the health. So the next stage of the model involves a sustainability aspect. This involves using some third-party software from Remmer, who are experts in life cycle analysis, and the information is sent from the Watson model using an API link into the Remmer software, which then reports back on various sustainability metrics. So from this we can get various reports. So here there's an example where I've looked at the effect of changing the protein source from soya from Brazil, which has a land use change factor, to soya from the US, which doesn't have a land use change factor, and also looking at using alternative proteins, looking at the effect that changing the protein source can have on the carbon footprint of the pork meat produced. So we can see that the highest figure comes from the Brazilian soya, as we'd expect, which has a very high land use change attached to it. Then if we compare this to the alternative protein sources, we can see that there is a reduction in the CO2 equivalents per kilogram of farm gate weight. But then when we compare this to soya from the United States, which doesn't have a land use change factor, this has a much reduced carbon footprint compared to both the Brazilian soya and the alternative proteins. So this can be used to decide on the protein source to be used in the diets. It also shows that not all soya is bad, and actually using soya without a land use change factor is more beneficial than using alternative proteins. Further information comes from the Remmer software. So this graph shows the contribution to the carbon footprint from the various different stages. So we can see that the smallest part is from the sows and the nursery, and the largest part is from the grower finishes. This is the stage in which they eat most feed. You can see here that when we're using the Brazilian soya, the amount of CO2 equivalents coming from the grower finisher phase is large compared to the alternative proteins and the US soya. So any changes we can make in this grower finisher phase will have a bigger impact than making any changes in the sow and the nursery phase. Another output we get from the Remmer software is to show the contribution by each of the raw materials to the carbon footprint. And this is quite useful in that it helps us to select raw materials to enable us to reduce the carbon footprint of the meat produced. So quite clearly, when we look at the Brazilian soya option, we can see that the Brazilian soya is contributing the most to the carbon footprint. Whereas we look at the alternative proteins in the US soya, and some of the other raw materials start to feature more heavily. So in the case of the alternative proteins, we see it's wheat, and in the case of the US soya, it's barley. So this can allow us to make informed decisions on where we purchase our raw materials, as these can have an impact on the carbon footprint. I've also looked at the effect of the number of feeds that are fed over the finishing period. And this slide shows the difference between feeding one feed, two feeds, or three feeds from the period of 30 kilos through to slaughter. So you can see by using three feeds, where we're more closely matching the nutrient profile of the feed to the requirements of the animal, we can reduce the carbon footprint quite significantly. Whereas if we feed one feed, this is limiting the amount of nutrients fed at the beginning of the phase and oversupplying nutrients at the end, which has a negative impact on the carbon footprint. I've also modelled the effect of improving the feed conversion ratio over the period from weaning to slaughter. This slide shows the effect of improving the feed conversion ratio from 2.52 to 2.15, and this has the effect of improving the carbon footprint by 11%. This does not include the effect of altering the number of feeds fed or changing the raw materials with regard to land use change. If we combine all of these factors, then we can have an even bigger impact on reducing the carbon footprint of the feed. So hopefully I've shown that the use of the Watson swine model can be very beneficial in helping us to reduce the carbon footprint of pork that's produced, and also help to improve the efficiency on the farm and reduce costs. Thank you very much.